There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium.
Hello, my name is Brock Haddon, and today I'm going to be showing you and explaining to you the idea of polar and nonpolar substances. I'll be demonstrating an experiment that shows by taking water with pepper sprinkled on top, the pepper will actually scatter to the edge of the bowl when you add detergent to the water. In order to do this experiment, you will need a bowl with water in it, pepper, and some detergent. You also might want a toothpick to put the soap on to dip into the water. Alright, let's do some chemistry. Alright, here we go. So we've got our bowl of water. We're going to sprinkle some pepper on top. And now I'm going to put some detergent onto the toothpick. And watch the pepper when I add the detergent to the water. Wow, amazing. Alright, now I know many people will be mind blown by what just happened there, but I'm actually going to explain to you the process and what goes on. So when still water is present in the bowl with no soap in it, it has what is called a surface tension. The surface tension is the strong interaction between the water molecules. Actually, water is considered to be a very polar molecule, so therefore it has a partially positive end and a partially negative end. As well, you can see in its shape, it has a bent shape. Since water is very strongly bonded to other water molecules, it actually has a higher surface tension than many other liquids. So this strong bond that actually holds water molecules together is called a hydrogen bond. And water molecules are so attracted to each other that some insects can even walk on water. Like, go figure. Alright, now detergents, on the other hand, are part of a group called surfactants, which is short for surface active agents. Each detergent molecule has two ends, a head end and a tail end. The tail end is actually hydrophobic, meaning it repels water, and the head end is hydrophilic, meaning it is attracted to water and actually wants to bind to the water. And due to this characteristics of detergent molecules, when mixed with water, detergent molecules prefer to sit on top of the water so they can have their hydrophobic ends sticking up into the air, and the hydrophilic ends are able to be in the water where they want to be. Now, although detergent molecules do have a region attracted to water, they are not as attracted to water as water is attracted to water. Like, water is literally in love with water. But anyways, back to science. When detergent is added to water, it breaks the surface tension, or it breaks the hydrogen bonds holding water molecules together. This is because water wants to get away from detergent, and when the surface tension breaks, it acts like an elastic, and all water molecules spread to the outside, as we saw in the bowl. It would be like, imagine having a tug-of-war with two teams, one on each side of a rope, and someone cut the rope in the middle right during the contest, and everyone flew backwards. That would be what the water molecules are acting like. Alright, there you have it. I gave you the idea of the surface tension, why the pepper is scattering when we add the dish soap, and also one more thing to note, the pepper doesn't actually play a role in the experiment except for allowing us to actually see that water moving. Otherwise, it would be hard to see. Gee, chemistry sure is fun, kids. Now try it for yourself and see if you're as amazed as I was. See ya!
Strontium and silicon and silver and samarium and bismuth, bromine, lithium, beryllium and barium.